Hello everyone, welcome to Harsh IT Lab. Harsh Sharma this side, and today we are back again with the reading of our book Network Warrior. And today we are discussing three topics: FEX, spinning, and VPC, which stands for Virtual Port Channel. We already had a discussion about these three topics little bit because we have not experienced the device in its physical nature, but we actually know what a FEX is, but a new concept is pinning. We already know the VPC, which is a kind of a Cisco proprietary version of the MC-LAC, and we will see what today the book has to offer. And for those who don't know about the book is Network Warrior that we are going through, and here it is the book. This book is written by Gary Donho, and this book specifically talks about the practical lessons which was missed during our CCNA preparation. Okay, so let's go to our terminal so I can SSH into my phone. And actually, I have already SSH it. So without any further delay, let's start the topic. So FEX. FEX act like a remote line card for a parent switch managed by a single system with zero installation or zero touch installation. So managed by single system stands that a single system is a single control plane or management plane. So FEX only extends the interfaces of a parent switch. Suppose we have a very advanced switch with a capability of handling much larger gigabits of data, but it does not have a much interfaces, so we can connect more devices to it. So we can use a FEX without having a headache of managing it by SSH into it or configuring it. It automatically shares the configuration from its parent. The next line says the FEX extends the parent switch fabric to the edge. So basically, it's a fabric extender, as its name suggests. It extends the fabric to the edge. Edge means maybe edge computing devices. So FEX can be attached using two ways. First is pass through, second is crossover. On a pass-through, FX act like as a blade in the switch. While in crossover, the FX connect with two different switches. It may be catastrophic to the network as it poses the risk of both switch thinking that that the FEX is extending their own fabric. So, as per my information, or as I have seen the diagram in the book, eh, the connecting FEX in a crossover section is like when we are preparing a single server with two different NIC card or with two ports connecting to different switches or different chassis. So, in order to provide redundancy, but it is fine on the server side. But when we do FEX with two other switches, it will create confusion that of which fabric does the FEX will become the part of. Okay, so FEX features need to be enabled in order to get it working through the feature FEX command in the interface configuration mode of the NXOS. We know that NXOS is kind of minimalist approach to networking where everything is disabled by default. We have to enable it in order to make use of it. FEX requires a description in form of locally significant number assigned between 100 and 199. So basically, it's required description or in order for tracking. Okay. When FEX port are connected to a switch, interfaces should be configured as following. Ether channel may be needed to form if multiple ports are being used, which is quite a discriminatory or self-explanatory thing. Descriptionatory. Okay, that was the word. Okay, so interface Ethernet 1 over 1 or 1 by 1. Switch port mode FX fabric. FEX associate 100. Already taught that it is a locally significant number. Okay, then FEX associate 100, 100, and then channel group 10. So basically, we are creating an ether channel, and interface 1/1 it will be part of channel group 10. And then when it's recognized, it will likely need to download the proper microcode. Once again, actually we have passed it. Yes, yes. We need to download the proper microcode for 5,000 or 7,000 to which is connected. So basically 5,000 or 7,000 is the category or series of the switch. switch may come inside of this series, for example 5080, 5500, 7080, like that, to which it is connected. This process can take 10 to 15 minutes and will involve the FX restarting. So it is basically termed as the initialization of the fabric extender. Now, uh, this is a new topic that we have not touched until yet. So please be aware. So pinning allows us to assign bank of port to individual uplink of having all ports share a single ether channel. Okay, so basically it's an alternative to ether channel. From our current understanding, what we use ether channel for example, we want an uplink. Uplink means a connectivity to the north side of the things, for example getting an internet from this. So for all the connected devices, which will there must be many, so for all the devices, we cannot use a single port to provide uplink. For example, if that port goes down, then every devices will be isolated from the network. So we have a solution known as Ether channel, which bundles 4 or 5 links. So it 4 links can be used as a uplink for all the remaining devices connected with using that switch. But because ether channel is, we are just bundling links and it does not make the links any faster. So we have an alternative. Let me first read this line, that ether channel is not really a faster link, but rather multiple same speed links balanced according to predefined algorithm. Okay, so instead of depending on a single ether channel, single virtual channel, we can assign a group of interfaces to a single particular interface. Basically, if we suppose we have 24 interfaces and we have a ether channel of 4 interfaces at the last of the switch. So we can use the first 6 port assigned to the first last port, a group of 4 ports. The second sixth group will be assigned to that second interface. Third sixth group will be assigned to the third interface, and finally the fourth sixth group will be assigned to that 4 interfaces, which will act like a bundle, but logically it's not a bundle. And we have an example written over here. At cost of dynamic healing, we can pin down the specific number of ports to a single high-speed uplink, reducing the oversubscription ratio compared to Ether channel. So we have a keyword here, which is oversubscription ratio. I want you guys to Google this oversubscription ratio in Ether channel in order to fully understand the topic. And if you require, I can also, but will it certainly take time. So I request you to do that. And if I found any single comment that I did not do it, or like that, I will certainly explain it in a next video. Okay, so pinning cases on 48 FEX. So suppose all host port uses one link, uplink, which is default ether channel interface. Suppose we have a 24 port switch in which first 12 port switch are assigned to some host. So suppose 12 hosts are connected to that switch. We are using the last port, the port number 24 as an, or the last 4 ports, port 24, 23, 22 and 21 as a ether channel bundle. So it will be the first scenario in which no pinning is used. It's simple as ether channel. We make the bundle of the last 4 ports and connect it to it uplink. Next scenario is the first 24 used first link while the second 24 used the second uplink. So this scenario said that that in our case, we were using a 24 port switch, right? So the first 12 port, we'll divide that batch of first 12 port into two halves. The 12, the 6 and 6, and the first 6 will be using a single link, which will be a bundle of the 21 and 22, while the second sixth batch will be used as a bundle of 23 and 24. So that will reduce the load over a single link, and it will allow 2 links to flow the traffic, and it will effectively better. And now the last scenario is each 12 port group uses its own uplink. So in our scenario, a group of 3 will be used to per uplink port. So it will enable us to balance the traffic more effectively. I guess you are understanding it, and I just want you to form a mental image that we have 12 ports and we have divided the port in equals. So in order to get a 12, we can divide it into three groups of three, 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 and 3. So for every 3 ports, we are assigning a single interface that will be used as an uplink for those 3 groups. So in the first case, when we were bundling all those 4 ports as an ether channel, so every for a group of 12, the single link will be consumed, and the ether channel is not that fast because it's algorithm dependent, and at a time only one link will be used for a flow. So in order to avoid that, what we are doing is to assign a 3 port to a single link, 3 port to a single link, and by correlating like this, it will be much easier to balance traffic, and this situation is called pinning. It's a too much to understand in a single go, but it is what it is. And our last topic for the day is virtual port channel. We already had a discussion regarding it. So VPC, which can be understood as a Cisco proprietary MLAG or MC-lag, multi-JC lag or multi-link aggregation group, aggregation of data plane with separation of control plane between two switches. So basically, two switches will feel like that they are two different switches, but they do share a same data plane. So their ports can be used to form ether channel. Ether channel is just an example. For example, if my computers or if my endpoint devices servers have multiple interface card, we can connect the single server to two different switches, and they will work simultaneously in order to speed up the data flow and redundancy as well. So it is also needed to be enabled as a feature first, and VPC feature requires a domain number which must match for all the switches working as a single virtual port channel. And just like STP, spanning tree protocol, VPC also has a default priority of 32768, and lower the priority makes the switch a VPC second, makes a virtual port channel, I think some form of leadership or root, VPC row. VPC requires a dedicated link to share the keep alive messages, and this link, in addition to peer link, which is configured as a port channel link on which VLAN trunks reside and data traffic follows. So VPC requires a dedicated link to share the keep alive messages. Okay, so switch can communicate with each other, and this link will not be used to share the data traffic as per my information, but you have to make. So if you don't mind, can I Google it so I can be sure as well? Okay, so let me open the Safari. Is VPC link is used to transfer data? Actually, I'm very likely sure that the VPC link will not be used for transferring the actual data, because both switches have its own uplink. So it will share or it will transfer its data using the uplink. VPC is just a management plane connection. So here is our answer. VPC link is used to securely route requests to resources inside a VPC without traversing the public internet, which enables the low latency private communication between the switches. It allows the API gateway to connect with resources in the virtual port channel, ensuring data privacy and security. And let me minimize it. Yes. Now, we may configure management interfaces as a keep alive link. It must be routed and has inter-reachable IP addresses. VPC rely on configuration on each side of the link to match exactly. And show VPC helps us to view the current VPC status, while show VPC consistency parameters, VPC with its VPC domain or global, will list all the discrepancies from both our and peer side. So this line, the my motive to write this line over here is that VPC is quite fragile. A single change in parameters may break it. So in order to find its consistency, we can use the following commands in order to find it. And that's it for this video. Let me show you the upcoming thing and how to maintain the consistency. Actually, Cisco has a feature called config sync, which itself sounds like very simplistic or syncing diagram stuff. auto configuration, but it's a kind of headache, and we will see that in the next video. And thank you for watching, and thank you for joining this video.